Okay, so welcome to 45, 45, 90 triangles geometry lesson. I'm going to act like a different person because I'm recording myself. I'm going to send it to somebody outside this class, so I'll be a perkier version of my usual self. Okay, so the notes are short today, and it's because there's just really one basic concept that we're going to cover, and it's about special right triangles. There's two types of special right triangles that we're going to cover. One is a 45, 45, 90 triangle. It's a triangle who has angles that are 45, 45, and 90. Okay? This is also called an isosceles right triangle. The only way to create an isosceles right triangle is to have two angles that are 45 and one angle that is 90. Okay? So, in a special case, because it's isosceles, I know that it has two congruent sides. Those are given here by x and x. So if I were to apply the Pythagorean theorem and to try and find the hypotenuse, let's call the hypotenuse h, I know that the hypotenuse squared would be equal to x squared plus x squared. Correct? Okay, then I could combine like terms. So I would have hypotenuse squared is equal to 2 times x squared. And then it's probably a good thing that the other day we covered simplifying radicals. Because if I take the square root of both sides, I'm going to have the square root of 2x squared. The square root of x squared is a perfect, well, x squared is a perfect square. So the square root of that gets to come out in front. And then I leave the square root 2 in the radicand. So it turns out that whenever I have a right triangle where the legs are the same, that I get a hypotenuse of the value of x times the square root of 2. So whatever the legs are, multiply that number by the square root of 2 and you'll get the hypotenuse. Okay, so that's it. That's the rule for a 45, 45, 90 triangle. That's why this is x, x, and then x square root 2. Okay, so let's do some examples. Example 1, I know it's an isosceles right triangle because I have two sides that are congruent and a right angle down here. So that automatically means that it's a 45, 45, 90 triangle. So I know that that other missing angle right there is going to be 45 degrees. The double tick marks show me that x is equal to 3. And then according to the rule for 45, 45, 90 triangles, the hypotenuse is going to have a measure equal to the leg times the square root of 2. So this is just going to be 3 square root 2. Okay. All right. So example 2 is very similar. Again, we have an isosceles right triangle. These two are the legs. So A is also going to be 2 square root 3.
How do we know it's an isosceles right triangle?
Just look at, I've got two sets of sides that are, or one set of sides that are congruent, and then a right angle here. So that's why it's isosceles right. So that means that it's got to be 45, 45, 90. Whenever you see in words isosceles right, that's going to imply 45, 45, 90. Okay. All right. So we know that A is going to be 2 square root 3. C is going to be the length of the leg times square root 2. So this is going to be equal to 2 square root 3 times the square root of 2. You should remember that when you multiply these, you're going to multiply the radicands. So you're going to get 2 square root 6. And if possible, then simplify some more. In this case, we can't simplify anymore. Square root of 6 is simplified. So this is your final answer for the hypotenuse there.
Where do you get the square root of 2 from?
You always multiply the leg length by square root of 2 in order to get the hypotenuse.
Okay.
Okay, that's the rule. That's the only rule you have to remember here today. Okay, now, so example 3. We recognize that we have a 45, 45, 90 triangle. So we know that these two side lengths are going to be congruent. In this case, though, it's a little bit different because I have the hypotenuse rather than the legs. So if I have the hypotenuse, I'm going to divide instead of multiply. I'm going to do the inverse operation. I'm going to divide by the square root of 2 in order to get the leg length. So if I do 10 square root 2 divided by the square root of 2, well then lucky me, the square roots of 2 cancel, and I just get 10. So D is 10 and E is also 10. Okay? The next example is basically the same thing. We have the hypotenuse. In order to get the legs, we're going to have to divide 4 by the square root of 2. So this is going to be 4 over square root 2. Am I allowed to leave a square root in the denominator?
No.
No, I'm not. So I'm going to multiply top and bottom by square root of 2. That process is called rationalizing the denominator. It means I take out the radical from the denominator. Okay, on the top I'm going to have 4 square root 2. On the bottom I'm going to have 2. Am I done?
No. So you
No.
can reduce it.
I can reduce that even more. And so this is going to reduce to 2 square root 2. So that's my final answer for y. And of course x is another leg, so it's going to be the same. X is also 2 square root 2. Okay? So if you have the legs, in order to get the hypotenuse, you multiply the square root of 2. If you have the hypotenuse and you need to get the legs, you divide the hypotenuse by the square root of 2. Okay? So here's a little application problem. Let's say that we have a square. Now, squares have 90-degree angles here, here, and here, and here. But when you draw the diagonal in, it's going to cut these angles in half. It's going to bisect the angles. So you're going to end up with 45-degree angles here. And I know that also because the sides of the squares are congruent. So I'm going to have an isosceles right triangle up here. So just pay attention to this right triangle over here. I know that this side is 10, so this side will also be 10. And so then the length of the hypotenuse is the leg times square root of 2. So what's the length of the diagonal?
10 square root 2.
10 square root of 2. Good. Okay. All right, so how do you recognize if you apply this rule, if it's a 45, 45, 90 triangle, or if it's an isosceles right triangle? Okay, that's the rule. You can go ahead and get started on your homework now.
You do square root times the square root, you multiply or not?